In this series of videos I'm attempting to repair and restore this HP9845B vintage computer. In the previous video in this series I got as far as replacing two of the failed ROMs on the PPU ROM card. So I used a couple of modules that I designed to replace the existing mask ROMs that had failed. We tested those, they seem to work, haven't done too much testing yet, but it booted up to the same point that it did with my breadboard versions that I'd made up to replace the failed ROMs, and using the logic analyzer it seems to have worked. It looks like our new modules are doing what they're supposed to. So as you can see, I've refitted the PPU ROM and RAM card back into the card rack, and that means of course I can refit the monitor. Now, one of the problems, there are two main complications really in working on these machines. The first one is accessibility, and although the outer cards you can actually put on risers, with this smaller monitor fitted there's a bigger monitor that is even more of a problem. But with this small monitor you can refit the outer cards, but you can't into risers, but you can't do the same with the inner cards, and in particular you can't put the two cards that we now really need to get to onto risers, and they're the interface cards between the backplane in the main unit and the CRT assembly itself, simply because if you tried to raise them they'd be so flimsy. This thing weighs about 10 kilos and it would probably just snap the boards off or damage the backplane connectors. So that's one of the complications in working on this. Now, if I need to, I can attach this with a ribbon cable and put it on a stand, and as long as we keep the ribbon cable fairly short, and for the basic testing we actually only need to connect the left hand interface. We don't need the right hand one at the moment. That's mainly for graphics. As you can see, I've taken the graphics cards out. We don't need those for testing the alphanumerics, and I know there's a fault on the main card, so I've taken those out so it doesn't mess with us. The second complication in dealing with this is that this machine, when it's running on its own operating system, works in a similar way to the Windows API that you may be familiar with, except this predates Windows by quite a significant time. So although Windows was deemed to be very innovative when it was brought out, the operating system on this works in a very similar way, but was developed a long time before Windows ever appeared. And when I say it works in a similar way to Windows, what I mean is that a lot of the functionality of the system, when it's running on its own operating system, is through the use of dynamic tasks. So they are basically blocks of code that are created and destroyed as required by either user actions or system level actions. So for example, the keyboard interface is really controlled when the operating system is running through a task, and it's like Windows, it stacks up and keeps a message queue. It has pointers for all the hardware devices, so it works in a very similar way. And the complication there is that if the system is not working to probably 96-97% of its capacity, then it's very unlikely the system is going to be able to run the tasks, and so none of the main functions will seem to be working, even though it's probably nothing wrong with those functions themselves. So that's the reason I've gone through the system in the order that I have. Now you can of course bypass all that by using a system test ROM, and then you can just treat it as a simple hardware device and test each part of it separately. I don't have the test ROM. Now I could go down the same route I went. If you've seen my series of videos on the 9830, I wrote a series of test codes, test procedures for that. Very simple, put them into a ROM, and then I could carry out very specific tests. I thought I'd do something different. I may have to resort to that later, but I thought at least initially we'd take a different approach just to keep things a bit interesting. And so for this, what we're going to do is try and make use of the operating system to try and figure out what's going on. There is some very rudimentary self-tests built into it, but nothing really we can use to help us. But we'll go as far as we can without resorting to test ROMs, but I suspect at some point we will have to go to test ROMs. And then ultimately, of course, we will run some proper test programs on this, but at the moment it won't run well enough to do that. And in this video what I want to look at is the alphanumeric mode for the display. I know it doesn't work, or at least not properly. Now, when I first got this, I did try plugging the monitor in, and what I was getting was a whole screen full of repeating bytes. It was pairs of characters, one after the other, just repeated over and over again. Now, if you're familiar with this system, you'll know that's fairly indicative. It's quite a big clue as to parts of the system that are working and parts that aren't. The display system on this is fairly odd in that it gives the operating system the ability to kind of jump around the screen in a kind of dynamic way. It doesn't necessarily need to scan every single memory location to refresh the screen. And also it's a 16-bit machine, but the characters are only 7 bits packed into 8 bits. And that means that each word in the RAM, and it uses a block in the PPU RAM in order to store the data for the display. And each of the 16-bit values can store 2 characters, and so that was kind of indicative with the repeated pairs of characters that it's at least accessing part of the control logic. It wasn't getting the correct data, but at least it was going through some of the motions of trying to do that. Also, when it stores these values in RAM, it doesn't store them as the same value if it's in the higher order byte or the lower order byte of the memory location. So if you got an uppercase A, for example, it can take on one of 2 different values depending on where in the word it's stored. So if it's stored in the upper 8 bits, then it will be stored as a particular value. If it's stored in the lower 8 bits, it will be stored as a different value. Also, the RAM values can have other meanings rather than just character values. They can be control values, and all of this is taken care of. The interpretation of those values, whether it's the graphics byte or alphanumeric, or whether it's meant to flash or be underlined, all that's taken care of in the hardware logic system. So needless to say, the hardware logic to control even just the alphanumeric mode on this is fairly complicated. And it begins life down on this left-hand riser, and that's got essentially it's a state machine, and the state machine is driven through 2 proms with a couple of counters providing the address. And luckily the patent for this machine does have not so much the listing, but the table of values for that state machine, so it's quite easy to fault find. You can just see what particular state the state machine is in by looking at the address that's on the counters, and then you can see if the output of the state machine and the proms are correct. They just feed into some latches, and then each of the bits that come out of the 2 proms is responsible for selecting a different part of the functionality of the interface. So it's quite easy to fault find. Now, without the monitor plugged in, it will appear to be dead, but you can provoke it into doing something by taking the NL or end of line lines being fed back to the interface low, and it will kind of force the state machine to do something. Now, that was working, it was doing something, it just wasn't doing the right thing. And as I said, when I first plugged this in, I was getting nothing but kind of static characters repeated on the screen. We've now got the system running to a much higher degree. It's getting further through the startup, but it's still not doing what it should. But what I want to do now is see if the machine is fundamentally running and if we just have problems with the ancillaries, which is what I now think is going on with this. So I'll move the camera slightly so you can see the display. Power this up, and see what appears on screen, if anything. Okay, I'll get this powered up and we'll see what appears. Take a few seconds for the tube to warm up. I haven't got rid of the cataracts on this yet. I'll do that later on if we can get the machine running. So nothing's appeared yet, just take a while to start up, and here we go. Okay, well, it looks a bit odd, but it's certainly different from what I had before, and also I can see some activity. Just going to try pressing a few keys and see. Well, that's interesting. We are getting characters appearing on the display in more than one place at once. If I press keys, so it's doing something. The system must be running to a fairly large degree, otherwise we wouldn't have any interaction between the keyboard and the display. Also tends to indicate that the control logic for the CRT is accessing the RAM, because that's where the data is being stored in response to a key press. I'm going to try pressing the clear key and see if that has any effect, and it does. It takes us back to where we started from. It's not what we want, but it is. So if we watch this line, for example, I'll just press some keys. We are getting something. I'll press clear and it takes us back. So again, it looks like the system is fairly largely functional, but also we're getting nonsense on the screen. I'm just going to try pressing another key. We'll try resetting. That does indeed reset. What I'm noticing though is that all these characters are not ASCII characters. They are characters, they're not just corrupt garbage. At least every other line is. But they are... Just checking. So this machine does have the optional character ROM. We'll have a look in a minute, but the board on the left in the CRT housing is the control logic for the monitor, and then there's the control logic in the leg as well. But the card in the monitor itself contains at least one character ROM for standard ASCII characters, and then there's an optional second ROM that's used to provide additional characters, and it looks like all of these, I can't see any standard ASCII characters on here at all. It is possible that the blocks we're seeing are coming from the standard ROM. It could be we've got a failed character ROM on this. So what I'm going to do, turn this back off, I'll move the camera so we can see the board, the logic board, and we'll start investigating that. Okay, so this is the character ROM I was talking about. So this is the standard character ROM that's in all the boards. This is the optional one. I'm going to try removing this and powering it back up and see if that has any impact on what we're seeing on the screen. Shouldn't really be accessing this at the moment, so it shouldn't make any difference, but I've got a feeling what we were seeing on the display are coming from this ROM rather than our proper character ROM, so it could be our original character ROM has failed. So I'll just get this removed and we'll see what we end up with. So I've removed the optional character ROM and we'll try and power this back up. I'll swing it round so we can see the screen a bit better. I'll power this back up and see if it's changed what's on the display. And as you can probably see, it has indeed changed it. All the characters seem to be pretty much invalid characters. So it could be our original character ROM has failed. And what we'll do is we'll just check that is the case. So if we look at the schematic for this, I'll just relocate the camera so you can see this a bit more clearly. So this is the schematic for the control logic in the monitor. And the two devices we're interested in at the moment are these two. These are the two character ROMs. This is the optional ROM, that's the one I've just removed. And then we have the base ASCII ROM, which is this one. And to control them, there's just an 04 gate. And it just inverts the signal between one and the other, so it selects one or the other. I'm just going to put a scope on here and see what it's doing. So that's IC20, which is this one. This is numbered from the top left, so counting across IC20, and we want to look at pin, you probably can't see this, it's pins 1 and 2, and we'll see what we're getting there to see which of these two is actually being selected. It should be predominantly this one, but I've got a feeling that this might have actually failed. It doesn't really explain why this was being selected unless the failure is on the input. Even that wouldn't explain why we're seeing data coming from this. So we'll get a scope on here and see what it's actually doing. Okay, so we'll look at pins 1 and 2 on this device, and we should see something other than that. So that's clearly not what we should be seeing. We'll look on the outputs. Okay, that is not a valid TTL signal, so I'm just going to turn the machine back off. So the signal we've just been looking at, the odd looking one, is coming from the input to this gate. It's an 04, so it could be that 04 has failed. This signal, this is the chip enable signal for selecting one of the two ROMs, and that comes from the riser card, and this is the schematic for that, and it comes from over here, and it's the output of a multiplexer. So it should always be either 0 or 1 within the limits of TTL signals, of course. So it's possible that, that's most likely, that one of these multiplexers has failed and is not giving out to the proper signal, not selecting the ROM. It's less likely now to be the ROM. It could, I'm hoping it hasn't been selecting them both at the same time, because that could have destroyed one or both of them. It could be the 04. What we can do is we can take out this card and look at the signal, because it comes directly from the edge connector going into this board. We can look at that signal on the edge connector to this control logic and see if we're getting a sensible value. The system won't run properly with this removed, but at least we'll be able to see if it's got a sensible logic level on this particular line. So I'll get this card out of the way and we'll see what the signal is on that line. So I've removed the alphanumeric logic control card. As I said, the system will not run properly with this removed, so we'll get probably an error tone after a few seconds. What we can do is attach the scope to that line that we were looking at and see if the value is correct. Okay, so I've got the scope on the same signal line, but of course with the card removed. I'll power the machine up. Okay, and clearly that's not a valid TTL value, it's just floating halfway between the two. So it looks like we've got a failed multiplexer on the interface card. So I'll get this taken out. It's very difficult, as I said, trying to work on these particular cards because we can't put them in risers. So what I'm going to do is just do some static testing on that device, see if we can actually detect anything with a multimeter, and hopefully it will show up and we can replace it. But I'll get this removed and we'll have a look at it while it's on the bench. So I've removed the card from the machine and we'll just get the multimeter onto the bench. Hopefully you can see this, try and get everything into the shot at the same time. And so this is the part of the schematic we're interested in, and this is the chip select line we were looking at, and it goes to IC24. Quick count. This one. Let's check that. It should go to A6. Which is that pin. And we'll just make sure we are getting that's onto pin 15, which we are. So that's the right IC, and it's pin 15. I just want to check to see if it's shorted to anything else. So that looks fine. That's interesting. It does appear to be shorted directly to pin 14. So pin 15 is the output. Pin 14 is a different line, it's a different control line. but these two seem to be shorted directly together, so we'll try. This is the same type of IC, so if we go to that one, you can see it shouldn't be shorted to it. That is a direct short, so either they've changed layout. Really can't see why you would connect the output, two different outputs of a multiplexer together. It's likely to damage one or other of the outputs, so I don't think they're supposed to be connected together. Now it is possible with this, it's a problem on the board itself. Let's try reversing the probe. It's still a short. Doesn't appear to be shorted to a rail, which is what I was expecting to see. It seems to be shorted to a different pin, which is very odd. So really the next step, it's possible it's the board, seems to be unlikely, but as I said, in these multi-layer boards I do sometimes find this sort of thing. You get internal shorts coming up, but the next step really is to remove this device, see if the problem is with the device itself. If it is, we'll replace it. We'll probably replace it anyway, but we'll go from there. So I'll get this taken out of the board and we'll see if it tests as faulty once it's removed. So I've removed the device from the board. We'll just quickly check the board itself. So it was between pins 15 and 14 we were getting a short, and there's nothing showing there, so we'll check the device itself. So we'll measure between these two pins, and we are indeed getting a short. So luckily it is the device, it's not the board. If you're interested, this is a 74LS298, so I'll fit a socket onto the board, fit a replacement, put the board back into the machine, refit the monitor, and we'll see if we can get any further. So I've replaced the IC. Unfortunately it was one of the ICs underneath this metal bracket, so there isn't space for an IC socket, so hopefully it will work. And as you can see, I've refitted the board, refitted the monitor, so I'll move the camera and we'll see if that's made any difference to what appears on the screen. I'll power up the machine and we'll see if we've made any progress. No continuous tone, so that's a good thing. It means the machine has at least started up to the point it was at before, so we haven't broken anything. And we have made some progress. It's saying ready to use, but it's saying it quite a few times, so looks like we've got a decoding issue, and so we've got a stuck bit somewhere and it's rereading the same memory location more than once. I'm just going to try pressing the clear button, see what happens. It just clear that text. Try pressing a few keys. I'll press the T key and we've got a T appearing, but it's appearing in several places at once. So press this a few times, try a few more keys, K, and we are getting the correct character. So at least it looks like the character ROM is working. We can see that we've got characters here that we shouldn't have, so we've still got some issues, but we are a big step further forward. We're getting odd characters from the numeric keypad. Okay, it's the same memory test, but clearly it's not doing what it's supposed to. Okay, well, it's a big step forward. We're getting something on the screen now that makes a bit more sense than we had before. Just try resetting it, and we go back to where we started from. So as you can see, the device we found was indeed faulty. At least we are possibly seeing that the character ROM is working. I'm not going to refit the second character ROM just yet. We don't need that, and I don't want to kind of confuse things. I won't bore you with too much detail. Let me know if you want to see more of this sort of thing. But the next steps are to go through, test the rest of the functions in exactly the same way as I did with this. So we can see we've got an addressing issue here by the look of it. So what I'm going to do next is just go through, check all the bits that are coming through. This is driven from the PPU, so I'll check that, make sure we're getting all the bits coming through the interface, make sure it's making its way all the way up to the control logic for the CRT, and hopefully we'll uncover something in the same way. It's usually fairly obvious, and you can see it's relatively simple to fault find on these. So hopefully in the next video we'll make some more progress and possibly get as far as running some code on this, but I suspect we still may be some way off that.